Let's see a problem in cengagae. A horizontal electric field E is equal to mg by q exists in space as shown in the figure. So this is the figure which is given in the question. So they are discussing about this. So a particle of mass m having charge q is attached at the end of a large light insulated rod. If the particle is released from the position shown in the figure, find the angular velocity of the rod when it passes through the bottom most position. So this is the position that they are referring to. So when the charge initially it is at this position, so when it is moving from here to here, so at this position at the bottom stage, what would be the angular velocity? That's what they are asking us to find. So to do this one, like E is the electric field which they gave, electrostatic field. It's a static one, and yeah. So to solve this one, we can use the concept of like net force, like work done by all the forces. Here in this case it cannot be zero, because in this case, as you can see, all the forces they are contributing towards kinetic energy. So the forces that we are speaking to, one is work done by tension, the other one is work done by gravitational, as this is having mass m, so they would work done by gravitational force, and the other one is work done by this electrostatic field. So if we write the corresponding equations, we'll be having like this: work done by tension, work done by gravitational force, and work done by electrostatic force. It should be equal to half mv square, which is the kinetic energy. As the tension is very light, it doesn't possess any tension. As the string is very light, doesn't possess any tension, so we can take it as zero. Work done by tension is zero. And when it comes to gravitational work done, so it is force into distance. So mg is the force, and distance in the diagram, the total length of the string is L, but from this position to this position when it comes, you can, like, we can see here. So from this position to this position when it comes, we can see the L, the total length, whatever it will come only up to here when it consider this position. So the total length will be L. I mean the total length L remains same, and from here to here, this specific length, this is nothing but, as we have theta as 45 degrees, so this will come as cos 45. I mean this will come as cos 45, as this is the resultant. So this is the resultant and this is the horizontal component. So here the it will be L cos 45, as total length is L. I mean this, if we consider here, this is the total length L. So what happens, this is L cos 45. So from here to here it will be L cos 45, and from here to here it's total length. So if you want to find this portion where we are exactly finding the difference, it will be L minus L cos 45, which is the distance for work done by gravitational force. So the same thing we can write here, mgl, I can take L common, it will be 1 minus cos 45. Okay, and electrostatic force. So the formula for electrostatic force will be Q E L sin theta. Sin theta is nothing but sin 45 degrees. This should be equal to half m v square. Okay, so in this equation we can take the common thing as m. So when we take common as m, we'll be getting here, if we take m as common, gl minus gl by root 2, because cos 45 is root 2, plus L we have m. Oh, okay, we can take only common up to here, and plus q e. What's the value of e? E from the question they gave it as mg by q. So if we write mg by q, q and q will get cancelled, so we'll be left with mg only actually here. So it will be like mgl sin 45. So I will erase this one, I will write the direct equation. So it will be mgl. Already we are taking m also as common thing, so we'll be having only L value. So L sin 45 value mgl, so gl by root 2 will be left here. After simplifying it, we'll be left with this value. It will be equal to into half mv square. Okay, so this will be the value. We can cancel m and m, so m and m will be cancelled. So we'll be left with gl minus actually I think 1 minus 1 plus, Okay, so these two will be cancelled, so we'll be left with only GL. So GL is equal to half V square. Okay, so from here we can get V square is equal to M also will be cancelled, sorry. So V square is equal to 2 GL. So from here V is equal to under root of 2 GL. But this is not the thing, we need to find the angular velocity. So for that one, omega is equal to V by L. So if L is the total length, V is the linear velocity. So V value we got it as under root 2 GL divided by L. So it will be finally equal to under root 2G. This L can be written as root L into root L, and this LL will cancel. So final answer would be under root 2G by L. So this is the final answer, which is the required one for finding the angular velocity of the particle at the bottommost position. Okay. Thank you.